Anyway, we should get started and get to our topic for today. Really excited to be doing this webinar with Hans. We're going to be talking about the Earthmover Data Marketplace and the AI-ready weather forecast data from Brightband that you can get on it. I'm going to kick us off here with just a quick overview of the Earthmover Data Marketplace and the Earthmover platform, and then I'll hand it over to Hans from Brightband, who's going to take you on a tour of some of those cool data sets that they've got. So let's take it away. Um, First, just a quick note about us, Earthmover. We are a startup on a mission to empower people to use scientific data to solve humanity's greatest challenges. The company was founded by myself and Joe, and we really come out of the scientific Python space. And so it's really exciting to be doing this marketplace where we're able to connect a bunch of the folks in this ecosystem in our network, both data users and data providers, and try and accelerate the whole ecosystem of cloud native scientific data. Why did we do this? Why did we create a data marketplace? I see three big trends that are causing some significant disruption in the Earth system data space. One of them is the rise of AI and ML workloads. Even before agents popped onto the scene, we've known that AI has a truly voracious appetite for data. It's not uncommon for a researcher or research team to want an entire archive of weather forecast data or reanalysis rather than just picking out a single point or a single file. Cloud computing is another very important trend going on. Cloud computing makes it possible and even easy for any organization to spin up large-scale storage and compute resources without having to do a big capital outlay. But a lot of our existing infrastructure and data systems were built around sort of very mature existing data centers at large governmental agencies and supercomputing centers. And those things don't necessarily translate that well to a cloud computing context where we have to use cloud object storage. And then finally, I'm very excited about the trend towards open science, wherein research teams in both, public and private sector are seeing new incentives to share their results of their research along the way, share intermediate results, and provide fair and open access to data and source code. So I think that's a great trend for the world and something we're trying to accelerate here. Now, traditionally, data have been distributed in this space of weather and climate by a big data provider. Think a big government agency. And the assumption is that a user is going to go download some files from that data provider and bring them over to their sort of local computer. And this is this thing that's specifically breaking down here. Typically, that download is providing netcdf or grib files. Sorry, I'm in New York City and there's like a massive siren going on behind me. Was that very disruptive? Okay,
You're good.
let me carry on. So, traditionally, we've been downloading hundreds, thousands of grib and netcdf files from these data providers. And then the team that wants to use those for operations or for research very often has to transform them, optimize them locally into something that's more useful for analysis or operations. That in turn induces latency and complexity and increases the cost of working with this type of data. So all of these things slow the adoption of weather forecast information, climate information, and create friction and pain for the data users. There's a new standard emerging, the idea of the ARCO data, Analysis Ready Cloud Optimized Data Cube. So in this paradigm, rather than distributing data as a bunch of files, we can provide a pre-organized data cube where we've got all of our variables, all of our time steps, everything in one logical object so the end user doesn't have to think about the individual files and can focus on their analysis. And then if we bring in the cloud optimized piece, that means we're storing data in a format that is fast to query, that provides good throughput for analytics and AI workloads, and that integrates well with other cloud-based data systems. And of course, at Earthmover, we're very excited about Ice Chunk and the underlying ZAR technology as a great way to store this data. Everything in the Earthmover Data Marketplace is Ice Chunk data. So I'm going to just say a little word about Ice Chunk and what it is. So Ice Chunk is a storage backend for ZAR. So it works together with the ZAR file format. And basically it makes ZAR go super fast in the cloud while also providing some really important features for production grade usage, such as ACID transactions, the ability to roll back your data, versioning, virtualization over other file formats like HDF, NetCDF, and TIFF. It's 100% open source. It's serverless. It's just the client talking to the object storage. And it's really the key to making this marketplace actually work well from a technical point of view. And so I have a very busy figure over here showing how fast IceChunk is at reading and writing data in the cloud, the fastest library out there compared to any other tensor or array-based storage engine. Go check that out. Now, at Earthmover, we really think of ourselves as building the Arco data platform. So IceChunk data is great, object storage is great, but we still need more layers of data management, query, and access in order to deliver a full end-to-end data platform. And so that's what our product is at Earthmover. So sitting on top of cloud object storage, we provide data catalog, access controls, webhooks, and other integrations. We have an API gateway layer called Flux that serves this data out into different formats, such as map tiles, CSV, Parquet, and even integrates with OpenDAP for all of those legacy applications. And the new thing we've just launched is the Data Marketplace, which provides the ability for organizations to create listings for data, subscriptions, metrics and logs showing usage and ultimately billing and monetization for organizations that want to go that route. So just to explain how this works, the marketplace works within our platform. Before we had the marketplace, we essentially had different organizations using the platform to store, manage, and query their own internal data sets. And Brightband was and continues to be a customer for this service. However, with the marketplace, we sort of enable this cross-organizational sharing of data such that one organization can access another's data in a secure, performant, and reliable way. Coming soon, we're going to have the ability to actually replicate this data across buckets. So if if organization B wants organization A's data in their own storage, in their own cloud region, that's going to be an option. So we launched this marketplace about 2 months ago with some fantastic partners, Brightband, Beyond Weather, Columbia Climate Uncertainty Lab, Dynamical.org, Subseasonal Consortium, Zeus AI, and Planet. We actually have a new crop that's launching next week, which I'm excited to talk about then. But today we're going to be focusing specifically on Brightband and the fantastic data sets that they're bringing. So just kind of to wrap things up here, let me talk a little bit about the benefits that we think this approach of a cloud-native data marketplace brings to both data providers and data end users. So for the users, we're looking to deliver instant access to high-quality, analysis-ready, cloud-optimized data, bypassing these costly and slow data ingestion and transformation steps that create a lot of friction and expense for data teams. We're focused on high performance, thinking about AI, ML, and analytics workloads. There's a lot of great free data, and those are completely free to access through the platform. And then we also offer commercial data sets that come with SLAs, and Brightband has some of these available as well. And so this is really meant for and ideal for data teams in industries such as energy, commodities, utilities, insurance, finance, agriculture, but also has a strong use case for academic research and reproducibility. On the data provider side, we're trying to make it easy for folks to distribute Arco data without having to build and maintain a lot of infrastructure around that. So we enable folks to share both free open data and private proprietary data through a single secure platform, all based on an open source format. we really strive to give data providers control and sovereignty over their own data by allowing them to choose where the data are stored, including bringing their own cloud, how data are licensed, and how data are priced. And then we give detailed usage metrics and subscription information to the data providers so they can make the most out of their subscriptions. Okay, so as for our roadmap, it's more data, bringing on new partners and working with existing partners to add new data sets, and then more features, filtered subscriptions, private data sets synced to your own bucket, and then finally layering more compute capabilities on top of the data to make it even easier to work with. So, just wrapping it up, our vision here is to really enable frictionless global data exchange in this new AI era. And I think the work that Hans and the team at Brightband are doing really exemplifies that. So I will stop there and hand it over to Hans to talk about what they've got going on.
Cool. All right. Thank you, Ryan. Let's see if I can figure out how to share my screen properly. Let's do this one. Can you guys see all that? Great. And maybe, for context, uh, for why Ryan's sitting here in the Bahamas, if you joined late, you should check out their latest blog post. They also have announced a new product that you did not advertise, Ryan. Nothing about Ice Trunk Coin here, but okay. Um, Thanks for the intro. Okay. Yeah, let's see. I'm gonna go over what Brightband is, what we've got in the marketplace, and then I'll try and do some live demos, which is always fun and exciting if that works, to sort of show you the use cases for what we've got. Um, okay. So let's start with who's Brightband. We're a public benefit corporation, working in the machine learning weather prediction space, a little startup, building some fun products, and also trying to help, just make AI weather stuff generally more accessible, with a combination of open data, benchmarking, and tooling. And I'm going to talk today mostly about some of the data side of this, and a little bit on tooling, if like Colab notebooks count as tooling. We do have some like other sort of non-marketplace initiatives. One, it's in Parquet, our Ninja AI data set. Ryan, we got to figure out how to like get this in the marketplace, but this is another like large data initiative that we have. And then Extreme Weather Bench is a benchmarking toolkit that we actually are going to touch on a little bit today, with cases and eval focused on extreme weather events. So this is kind of like something that might kind of touch on the sort of scientific research and reproducibility side of what you can do with the marketplace. But we're not here for these things. We're here for the marketplace. So, why are we Brightband here in the marketplace? I'm not like a salesperson necessarily, but I'll tell you what I think the big reason is, which is that it seems supernatural for us, right? We've been putting forecast data in Array Lake for a long time now, as Ryan said, more or less since we've had SAR-shaped data. And we've been working with Earthmover for a long time as well now. So when they approached us about the idea of the marketplace, we were super happy to work with them as a launch partner. Um, and yeah, so I'll spend a bit more time talking about exactly the data sets that we're starting with and why, but just in general, like I think that this kind of product is something that the community really needs. It's the obvious next step after sort of putting a bunch of ZAR stores in a cloud bucket and saying, here it is. We're also seeing that sort of data consumers, right? The sort of people who like to buy forecast data are becoming increasingly more sort of on board with the idea of just sort of accessing ZAR data. A lot of them just want, access to ZAR-shaped data in some way. And so, this as a marketplace and the sort of delivery format is being, access to, I'm gonna say ZAR-shaped. I mean Ice Chunk, right? I mean Array Lake, but like this type of data, people who just want to do XR open data set on something and then get their data and stream it to their own workflows. Like we're seeing this is the thing that people actually want at this point a lot more and more, which is great. Couple other points here. We process a lot of publicly available forecast data to Ice Chunk stores. We think people want these as well, right? This sort of speaks to our mission a little bit, trying to enable access to some of these data sets. And ultimately, we think that like grid interactions should be minimized as much as possible. The like Ryan said, data disseminated through some of these sort of legacy formats often isn't just the most sort of cloud friendly to work with and not the easiest to work with. Um, and then, yeah, one more thing here is that, we spend a bunch of time engineering around these data sets and producing what we think are really like nice, well workable versions of them. We think people are not going to save themselves some engineering costs and just pay for them and get them from us. And the marketplace is an obvious place to sort of put that and make this accessible to people. Um, and then, one final point here is that the marketplace is, yes, Margaret, what's up?
I am just wondering, Hans, how much engineering effort you think people save themselves by actually taking out the subscription? Because that feels like I've seen all of you all work. I've seen how much work it is, and I'm just curious what the actual replacement cost is.
That's hard to estimate, I'm sure, but I mean, for me at least, like we spend a lot of time building these sort of ZAR-based stores, and especially dealing with some of the sort of inhomogeneities in some of these stores, right? And not just the processing and uploading of them, but just dealing with the fact that they might change from day to day, like that's always sort of a stumbling block. Um, this could be a full-time job for someone is just, working with these data sets and sort of reprocessing them. There's also just like a sort of cost of just like compute cost of running with these things, right? So not every sort of GRIB available data set is in any way like you might just have to download petabytes of data or terabytes of data to work with it. Um, you know, uh, Using like leveraging an ARCO format like ZAR to store these things and just have people grab just the bits that they need is just, it's minimizing wasted compute. You're not necessarily pulling, gigabytes of data to access a few megabytes
Thanks,
of it.
Hans.
Yeah,
I
use
I,
government
I
for.
think yeah, I think everyone who's ever tried is grateful that there's a different way.
Yeah, for sure. Cool. And then yeah, so that's sort of like some of the reasons that we're excited about the marketplace and we're putting some stuff in it. And then to something that Ryan said earlier too, there's a mix of different use cases here. And for Brightband, we're a PBC like Earthmover. We have a business motivation as well, but obviously we have a mission statement to sort of democratize AI weather technology, and a big part of that is data access. So we have sort of a mix of paid and free data in the marketplace. So let's just hop to what we've got in there so far. Right now, we've got six data sets that are listed in the marketplace. We've got four free ones. We've got one paid one and then one sort of paid coming soon one. There's a few more coming sort of down the pike as well. I can talk about those at the end. But really, you can just see by color here, there's kind of three different sets of data in here that are sort of similar. And so let's just begin by beginning with the first one here. This is our machine learning weather prediction forecast archive. This is an example of sort of like a reproducibility and sort of like academic research focused archive. Is a 4-year reforecast initialized with ECMWF HRES of GraphCast, Pengu Weather, and AIFS single. It's 15-day rollout, 4 cycles daily for the 4 years here, 2021, 2024, quarter degree global. There's currently 5 key variables in this. We actually have a lot more that we want to upload. There's like a sort of barrier around how we egress this from our cloud to where we're currently storing it that we can talk about if we want to. But if you look at this and you're saying, hey, this is great, but I want more variables or whatever, just please come talk to us. We're super happy and responsive to like expedite adding things to this archive as we have them. Um, Big use case for this is a reference data set for benchmarking here, supporting our own extreme weather bench research. Um, Taylor in the chat, I'm sure, answer questions on that as well. But also you can use this for other types of benchmarking eval. You can do visualizations based on this. It's openly and permissively licensed. And I think this is kind of a good example of like the best type of like the best way to meet like open data requirements for publications, right? So a lot of journals now, you're publishing a paper, they say that you should have the data to reproduce the work be accessible. Um, you see people sort of say, oh, we downloaded the source data from Mars and then we ran the forecast with open weights, and you can go do that yourself if you really want to reproduce it, and good luck and have fun. Which is a lot of effort to then and go and actually reproduce it. The sort of compute cost of making something like this is really high. And so we think this is just like a better example of how to truly have reproducible research, or just publish the data, publish it in an accessible store. The marketplace offers sort of documentation alongside it as well. And so Yeah, so this is kind of one use case here. The rest of our stuff is more focused on operational work. So I'll jump to the second set of products that we have in here. This is ECMWF IFS HRES 15-day forecasts. And I've got two listings here, and they're similar in a lot of ways, and then a couple key differences. So I'll talk about how they're the same. Uh, so yeah, like I said, it's ECMWF 15-day IFS forecast. It's the official data from ECMWF, 4 cycles daily, 15-day rolling archive. So we truncate this as we update a new forecast. We lop off the one from 15 days ago. Resolution, it's hourly at the start. This is just how it gets disseminated to us from ECMWF. 0.1 degree global, 11 key surface variables. This is, again, to kind of keep the costs sensible and bounded here. And the main use cases for this, I mean, it's the list Ryan gave at the beginning here. It's anybody who's using the world's sort of eminent weather forecast to do anything operational. So, traders, commodities, energy. A lot of folks consume this forecast. You can get it here if you don't like getting GRIBs, or if you want to have it, just in a sort of more cloud-friendly way. There's sort of free use and commercial use based on this. So I should probably talk about what the differences are between these two. There's a free version. So the top one here is it's this forecast as described. It comes out a little bit before open data. You might look at this and think, actually, I can get this data through ECMWF's open data program, which is like a really amazing free data program. They disseminate tons and tons of forecast data for free. They disseminate it as GRIBs. And so, one advantage of getting it here is it's not GRIB, it's in ZAR. It's just, XR open data set, point at this, and you're good to go. This comes out a little bit before open data. So this is actually the fastest way you can get this data for free. And it's 0.1 degrees, right? Which is higher resolution than what's in open data. So there's like, if you're currently building apps on top of open data, like you can consider this. Taylor, again, in the chat has built some apps on top of this. He can attest to, it's much easier to work with than like GRIB parsing. So that's the free version. And then we also have a second version here, which is same data, but paid. And so, this I think is really exciting for some folks maybe who are, building commercial tools on top of IFS forecast here. So this is, as far as we're aware, the lowest possible latency ARCO version of this data set, right? So we get it from ECMWF as soon as we can, and then it is within sort of seconds, not minutes, uploaded and accessible here in this store. So this is the fastest way to get this data, unless you have extremely optimized GRIB parsing, then maybe it's possible. But that's where Margaret's talking about this engineering cost here. Like probably this is faster than anybody's or almost anybody's sort of like GRIB-based workflows. So yeah, that's our forecast data here. And just one thing I want to kind of highlight here is this is kind of sort of highlighting how we think about balancing the sort of commercial side and the sort of community and open data side of this. The people for whom latency is really, really important, it's sort of commercial users, and so they can kind of pay for the latency version. And then for most folks, having a like friendly cloud accessible version of this for free is worth a ton. And so that's how we can kind of a little bit have our cake and eat it too on having something be useful to everybody. And then the last set here, this is our third bucket of data sets, which is initial conditions. And so again, we have sort of three different versions of a similar data set here, sort of same free and paid dimension. And then there's also this ensemble versus sort of single control member dimension as well. So how are these the same? These are all ECMWF IFS initial conditions from the official forecast, either HRES, which is the control forecast, or ENS, if you're familiar with these things. This is their product names. 4 cycles daily, 15-day rolling archive, quarterly global. And the point of this is that these are what you can use for initializing MLWP models, which we do with it. Lots of people want to do this with it. So the sort of set of variables we make available is the set that you need to run sort of the most used AI forecasting models. And I will show you a demo of that if we can get to it in a bit. And then, yeah, I mean, so there's a free single version, there's a paid single version. It says coming soon. We do have this available, so come talk to this. You can talk to us now if you're interested in this. And then the ensemble forecast version here it's the same idea, except that instead of just the single control forecast, it comes from all 50 all 50 ensemble members. This one's based on open data that comes out a tiny bit later. So that's it. That's those are the 6 data sets we've got. Got archive, reference forecast, initial conditions. What's coming down the pike? We're currently working on ensemble forecast products, both ensemble stats as well as full ENS ensembles. And then again, we're thinking about sort of free and paid in the same way. There are also some key sort of reference AI-based forecasts that I'd like to add, AIFS and AI GFS or Eagle, as it's called from NOAA now. These are also sort of on our roadmap. And then as for our own MLWP archive, we actually are running all those models, GraphCast, PenguWeather, and AIFS single, operationally as well. So getting that to be sort of a little more real time is also on the roadmap. That brings us to demos. Ryan, how are we on time?
We're good. Carry on.
All right, cool. Can you guys see my screen? Yes, great. Okay. So where is this data? You go to the Earthmover Marketplace and you can see, Brightband here. You can see these ones here. I'm going to walk through the notebooks, the example notebooks that we have on these repos. What is this? Polls, quizzes.
I'm sorry, I didn't know you would get it, Hans.
I got it.
I'm
I
just
love
collecting support for Deepak's FCK GRB sticker idea.
I can't
Which will
vote,
be
unfortunately. Okay. Great. So if you go to, let's say, the MLWP Forecast archive, you can go to the README, and then you can see all the details on this here. We can talk about questions on this, and there's an example notebook. And this is that example notebook. Just to I ran these like just before the meeting, so the timings are accurate. I don't want to waste time, building environments and stuff like that. But it's just an example of what you can do with these different data sets. With the forecast archive, you load it. It's pretty easy to load these things, right? I think most folks here are familiar with working with Xarray, but this is just like how you load things from Array. Like if you're not used to it, you have the repo name, right? This is your own repo. Client get repo, get a session from it. Whoops, that's not right. And then you just open session.store with a group name. That's it. And then you've got your Xarray data set loaded right here, obviously lazy loaded, and you can make maps with it, right? This takes a second to make this map here, half a second. Or you can do case study analysis. I see your hand, Jonathan. Let's get this in a sec. In this case, we're looking at a heat wave for Denver from 2024. This was like a particularly hot day. You can spend a few minutes, or sorry, seconds loading this data. How long does it take to load? I think this took, yeah, seconds to load, 18 seconds to load the data. And then you can plot, for a particular case, how did these models validate against that? Jonathan, I see a question. I'll take it. You're on mute. Do we have to unmute you? There we go. Okay, I'm gonna keep going. If there's a Q&A, type it in the Q&A. Next data set here. I'm also not going to run through these just because, again, this takes a sec to plot them, but I did time all these so you can see how long it takes. This is our IFS data. So here we can plot. This is the most recent IFS 0.1 degree forecast precipitation, total precipitation global forecast. You can plot it in 700 milliseconds. Boom. It's great. One thing that I probably should mention here is that the way that we've chunked these data is sort of what we're calling pancake style. That means that for every time slice, you have a global single chunk of data. It does mean that some types of access patterns are a little less efficient. So for instance, if you want to plot for every forecast for one point in the world, what does that forecast evolution for that particular location? You are now accessing lots and lots of chunks of data. This is like 50 seconds to load all this data, but now you can see for New York, what's the sort of total forecast evolution over the last, I don't know, 10, 15 forecasts or so of T2M for New York. So it's going to get cold here in a few days, I guess. And then this is the last one that oh no, we're going to have to run through this one. No, I did time all these, so we don't have to do that. This is the exciting one. Last one I'm going to talk about here, which is running AIFS, ENS off of Brightband data. So this is, I think, my favorite notebook here. There's a little bit of mess with setting up the environments here, but it's all in the demo notebook. You can connect this to a Colab G4 runtime. So you have to connect it to a GPU to get this to run because you're running an AI weather forecast. How do you load the data? Client get repo, Brightband repo name. There's a tiny bit of renaming you have to do because of differences between our names and AFS's preferred names, but it's just, this is it. This is all the code you need to like open our repo, process it to the preferred shape that AIFS needs. And this is not important. This is not an important timer. And then it takes, in this case, 50 seconds to load all the data and importantly, regrid it. So this is 50 seconds because we're regridding it from quarter degree to N320, which is the preferred format or the shape of the data that AIFS needs. So this is mostly like data transformation, not data loading. The data loading is very efficient. And then you just run it. You can run AIFS. It's extremely fast. So for running a 3-day forecast here, it takes, sorry, what was that? Oh, there's no timer on this one. It takes like, oh, there we go. 9 seconds to run this forecast. No time at all. And then you can plot it. And then this is, a forecast that we initialized off of the most recent IFS initial conditions. Took 9 seconds to run. So within like a minute, you've got an ML weather forecast. That's my demos. Questions? Ryan, how should we do Q&A?
Well, I have a few questions I want to just throw your way before we carry on. As for Q&A, you can ask questions in the Q&A, or you can just raise your hand and speak up. Jonathan has raised his hand again. Do you want to speak up now, Jonathen? Can't quite tell. Okay, the hand went down, so I'm guessing he doesn't. So, I just. Yeah, let me ask you a few questions, Hans, to kind of kick this off, and then we'll see if there's any from the crowd. But first of all, thank you for sharing. It's super awesome. I would like to know a little bit about, and others probably want to know a little bit about what's kind of under the hood, right? So I think a big part of the value here is that for folks who are interested in low latency data, there's a very, very fast transformation that's happening from GRIB to Ice Chunk. And so tell us about, starting from the ECMWF source subscription, how does the data flow through this and how does it ultimately end up in the marketplace?
Yeah, so ECMWF, you can go to them, you can pay for a commercial license and you can order data from them and they have an option where they will ship it to you as soon as they produce it. And so for any commercial users who are serious about timing, this is the go-to option. You can go and sign up and say, I want these variables and this forecast product and this region or whatever. And then they will push a GRIB file or a series of GRIB files every time they roll out a forecast to your cloud bucket. And so we do that. We subscribe. We set up the option to get it as soon as possible. The data that you see in our marketplace listing is the data that we're subscribing to from them. And then they give you a bunch of GRIBs, and they give you one GRIB per time step. We have notification, pop-up notifications triggered off of the bucket that triggers a Cloud Run job that runs a small custom little like a little binary that we actually co-developed with folks at Earthmover, and that is Rust based. It basically glues together the Ice Chunk Rust library and GRIB tooling, and within a few seconds extracts just what it needs from those GRIBs and puts them in Array Lake and commits the data. So you're saving the time it takes to run is the time it takes to read objects from disk, basically, and upload them into Array Lake with like no extra overhead on that. And so, the sort of total runtime on this for the sort of fastest possible thing is really just measured in seconds. And so as the data rolls in, it rolls onto Array Lake, right? So and then it's accessible, and it's sort of like you can access it per variable, and it's the way it's chunked. And so that is like that's the pipeline, right? There's nothing truly magic under the hood other than like very like efficiently built and trimmed down libraries to make this all work. Yeah, does that kind of answer your question, Ryan? Did I get to most of it? I mean,
Absolutely, yeah.
that's for the low latency version. The paid version, we just sync it over. So we have another job that just at a certain delay just copies that data over, syncs it over, and so it's the exact same data, just with a delay.
Cool. We've got a question from someone in the audience. Manergy is asking, is the data available on marketplaces, AWS, Azure, GCS, always kept in sync with what ECMWF publishes on your website? Or is there typically a lag between the two? So maybe I'll just edit this question. We can't really tell you about other marketplaces, AWS, Azure, GCS. Those are not under our control here. We can just tell you about how the Earthmover Data Marketplace works. And maybe Hans, you can talk a little bit about the consistency between what ECMWF publishes and what's available here.
Yeah, so there's a couple of things. So in terms of what ECMWF publishes, if you're referring to the Open Data program, I mean it's the same data other than that's sort of quarter degree. The like so it's the same data stream, right? What they push there is what you could subscribe to from them as well and put in the marketplace. Some of our data is based on what they publish in their open data, right? So I mentioned those initial conditions, which is based on what they publish. And then, we don't, if they're not in the business of like doing amended forecast, right? If they issue a forecast, that's kind of what the forecast was for that day. So there's no real need to like go back and update things. Yeah, I would say the other case where that might be a thing is like with something like Era 5, right? Where they do sometimes say oops and like issue a correction to it, but it's extremely rare on their side. We're not publishing that data right now under Brightband. So.
All right, awesome.
In terms of the lag between the two, yeah, I mean the lag between them publishing it, like if you subscribe and us publishing it, the low latency is absolutely minimal, right? It's seconds. And the lag between open data publishing and ours actually we're a little earlier. So hope that answers it.
Cool. Taylor's got a question. I think this is more for me, but it's about how do users reach out to see if they can include their data on the marketplace? What types of data does Earthmover prioritize getting online? So I think that's a great question. So we're actively working on bringing as much useful data as we can to the marketplace. I really see our role a little bit as a matchmaker, right? We provide our platform to a lot of very heavy operational data users, folks in energy and commodities, in the financial sector, in utilities, and also a lot of startups who are using data in very innovative and intensive ways. And so we have a kind of sense of what data people are using, what data people are interested in, and then also who might be a good supplier for that data in the marketplace. So in general, we're very open to working with new data providers. You can find some links on our website and on the marketplace itself if you're interested in participating. I would say we are prioritizing things that are relevant to near real-time forecasting and weather and other environmental properties right now. We're also expanding to include some more climate data. So there's some very interesting downscaled climate data sets on the marketplace, and more coming. And then we're starting to break into Earth observation data. So more high resolution land-based data derived from Sentinel and Landsat type satellites. And we'll be announcing some of that next week. But in general, if folks want to get their data out there, we're very eager to work with them. What makes this different is that it's not file-based. It's aimed at low latency, and it's aimed at data sets that are updated frequently or continuously. So that's how we're different from other ways to distribute data. Um, I think we're through most of the questions. Um, I guess I'll toss one more at you, Hans. You know, I think folks might be curious to hear a little bit about what it's like for you as a user of the Earthmover platform to interact with this technology. What role does this play within your own data systems, and what problems does it solve for your team?
Yeah, so I think maybe for that I can kind of speak to it as like as an internal user and then separately maybe as sort of like a marketplace provider. So internally, we have lots and lots of sort of ZAR store shaped data. Um, it uh it can live on S3, right? You could just put on an S3 or GCS and have it there. But it's slower to access and it's kind of hard to remember exactly what you have. And it's just, if you're trawling over like years of reforecast data, it sucks if you're like just scanning, bucket prefixes and trying to kind of glob it all together. And so, our sort of like goal is to always put it into Array Lake as a reference forecast. Operationally, we also have a lot of stuff that kind of flows through Array Lake. And the big benefit there is honestly just like the right safety, right? That we don't end up with like accidentally corrupted ZAR stores that were, from tasks that were canceled halfway through a write or something. Um, and then as a data provider, I mean, for a few of these data sets, we just had them internally and it was very low effort to just say, hey, this is just based on open data or whatever. We should publish this in the marketplace, make a listing, tie it to a repo, and then go publish it, right? So like I would say moving between sort of our internal, like using Array Lake as a platform for our own sort of like, uh, data holdings and then listing them in the marketplace was like a very like low effort move. I mean, honestly, writing the documentation page in the example Colab notebooks is like the hardest part. So yeah, hope that answers that.
I think you just answered Taylor's question, Hans, and a few others. I was just going to ask the low latency versus the free data sets. Like, how do people choose between them? Because there have been a couple questions about like time lag.
Yeah, I mean, the free one's free. And so if you're building a fun little app or something where just having it available in a clean format is what you care about and you don't want to pay any money for it, like you use that one. Um, if you're a commercial user and you're deriving value out of something you're building off of this, right? You're whatever you're trading with it or you're doing something else. I don't know, you're doing like Kalshi prediction market stuff with IFS or whatever. I don't know. I wouldn't do that, but you could. The low latency stuff makes sense, right? Because then you have time to work with the data. And so that's I think the biggest split. You can also demo with the free stuff, see if it works, see if the data flow is kind of what you're looking for, and if you can build off of it. And then if it turns out that works for you, you can say, okay, what if I want this data a little bit earlier? And then you can move to low latency subscription, which at that point would just be, you know, get the commercial license, change one line of code in the repo name, and it's the exact same workflow. So
Awesome. All right. Well, I think we've reached the 45 minutes that we had scheduled here. So I want to really thank you, Hans, for taking some time to tell us about what you're doing. Thanks to everyone who joined the webinar. And of course, if you're interested in learning more about these data sets, we'd love to talk to you. Reach out. You can reach out to Hans. You can reach out to us at Earthmover, and we'll try and get your questions answered. Okay. I think that's it for today. Thanks, everyone, and see you on the next webinar.
thanks.